Welcome back to the class on a no-load and a block rotor test and a single phase induction motor. Generally, we are going to conduct a no-load and block rotor test and a single phase induction motor to find the equivalent circuit parameters of induction motor so that you can do the theoretical analysis on the single phase induction motor. First, we are going to see the block rotor test and a single phase induction motor. The name itself, it is their block rotor test. Nothing but we are blocking the rotor of a single phase induction motor. We are applying very less amount of voltage through the auto transformer. Whenever this current reading is equal to the rated current of induction motor, then you note down the readings of voltmeter, wattmeter and ammeter. This is the table. VBR is nothing but how much voltage you apply to the induction motor during the block rotor test. IBR is nothing but how much current is taken by the induction motor during the block rotor test. PBR is nothing but the power taken by the induction motor during the block rotor test. We are trying to develop the equivalent circuit of induction motor during the block rotor test. Now we are starting with the approximate equivalent circuit of induction motor. This where we neglected the core loss resistance. Whenever we are blocking the rotor, the slip of the induction motor is equal to the 1. When the slip of the induction motor is equal to 1, here R2 dash by 2s becomes a R2 dash by 2. Again this value also becomes a R2 dash by 2. This is very small value when compared to this branch. So the resultant impedance becomes a small impedance. The same manner here also, this impedance of this branch is very small this compared to this one, both in parallel. So the parallel combination becomes a very small impedance. This is the equivalent impedance of a induction motor during the block rotor test. This is the stator resistance. This is the stator leakage reactance. This is R2 dash by 2. This is R2 dash by 2, where S equal to 1. Now the block rotor test RBR equal to PBR by IBR square. From the equivalent circuit, RBR equal to RS plus R2 dash by 2 plus R2 dash by 2. So RBR equal to RS plus R2 dash. We know the value of RS, nothing but stator resistance. Then we can find out the R2 dash equal to RBR minus RS. So in this manner, we can calculate the two parameters. One is the RS, another one is the R2 dash. Impedance of a single phase induction motor during the block rotor test. ZBR equal to VBR by IBR. The leakage reactance equal to XBR equal to square root of ZBR minus RBR. From the equivalent circuit, XBR equal to XS plus X2 dash by 2 plus X2 dash by nothing but this one plus this reactance. If you simplify this one, you are getting the XBR equal to XS plus X2 dash. Practically these two values are equal, so XS equal to X2 dash equal to XBR by 2. Here on XBR by. Now we are going to conduct a no-load test on single phase induction motor. During the no-load test, we are applying the rated voltage to the induction motor. Whenever you apply the rated voltage to the induction motor, then you note down the readings of voltmeter, wattmeter and ammeter. So whenever we are saying the no load, nothing but we are not applying any load on induction motor. The rotor speed is equal to the synchronous speed of a induction motor. So the slip of the induction motor will be very lesser. This is the table. You note down the voltmeter reading VNL. This is the INL. This is the PN. Again, we take approximate equivalent circuit of induction motor where we neglect the core loss resistance. But in this case, now we are going to develop the equivalent circuit of induction motor during the no load test. But here the slip of the induction motor is very lesser. When you come to this resistance R2 dash by 2s, S value is very lesser, nothing but this value is very higher. So the impedance of this branch is very higher, that is parallel to the small value. So the resultant value becomes a Xm by 2. The same manner, if we come to this branch, S value is very lesser. So this resistance value becomes a R2 dash by 4 plus JX2 dash by 2. This is very small when compared to this one. The resultant of the small and high value results the small impedance. So finally, this is the equivalent impedance of a single phase induction motor during the no load test. First, we are going to find out the no load power factor of induction motor during the no load test. That is cos theta NL equal to PNL by VNL INL. The equivalent impedance of induction motor during the no-load test, ZNL equal to VNL by INL. The no-load reactance of induction motor during the no-load test, XNL equal to ZNL into sin theta NL. We can also find out this value from the equivalent circuit of induction motor from this equivalent circuit. From the equivalent circuit, XNL equal to XS plus this plus this reactance plus this reactance. So we have to find out the Xm by 2 because we have not calculated this value. So the magnetization reactance by 2 equal to XNL minus XS plus X2 dash by 2. We know this quantity, already we know this quantity. So we can easily calculate this value, that is magnetization reactance by 2. So from this equation we can calculate the magnetization reactance equal to 2 into XNL minus XS plus X2 dash by 2. So in this manner we are going to calculate the what are the parameters are required in a single phase induction motor. All those parameters we calculated. First one is the RS, second one is the R2 dash, mathematical rotor resistance referred to the stator. Third one is the stator reactance. Fourth one is the rotor reactance referred to the stator. Lastly, we calculated the magnetization reactance of a single phase induction motor. Once we know the parameters of a single phase induction motor for given induction motor, then we can easily do the theoretical analysis so that we can find the parameters of a induction motor. Thank you very much. If you have any doubt, you can ask me directly or you can ask in the comment box of my YouTube channel.